Hello, this is Scott Strack doing some math. Today in geometry, we're going to be proving triangles are congruent by this SSS thing. SSS stands for side, side, side. And basically what it says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So let's draw a picture of that. Hopefully I can draw two congruent triangles. Let's pretend those are congruent. So A, B, C, D, E, F. So if this side was congruent to that side, this side congruent to that side, and the bottom is congruent to the other bottom, then I can say triangle ABC is congruent to triangle DEF. Alright, so example 1. Given that JF is congruent to JH, so this segment is congruent to that segment, and G is the midpoint of FH, okay, prove that these two triangles are congruent. Alright, let's go. So this is a proof, because it says proof. Statement, reason. Okay, number 1. Always start off with what you're given. So JF, the segment, is congruent to the segment JH. So it's given. 2, G is the midpoint of FH. That's also given. Okay. So we want to prove that these two triangles are congruent, and we now have two ways of showing that triangles are congruent. So the first way was to show that all corresponding parts, so not only the three sides but the three angles are congruent. Now all we need is just three sides. So, and most likely since we're learning that today, we need all three sides. So we have one side, JF and JH. So we need the bottom pieces. So we need, okay, let me use a different color here. So we need FG to be GH. And right now we can actually show that. So FG is congruent to GH. Why? Because G is the midpoint. So if a point is a midpoint, then it divides the segment into two congruent segments. Okay, so once again, they gave us the fact that G is the midpoint of FH. That means FG is congruent to GH. If a point is a midpoint, then it divides the segment into two congruent segments. Okay? So the next thing we're missing is the third side. Well, the third side is JG, this red line here. And both triangles use that. So I can actually say JG is congruent to JG. So I am myself, so remember that is reflexive property. Okay. Now, do I have enough to show that these three triangles are congruent? I got one side, two side. So I got the black side, the blue side, and the red side. So that's all three sides. So that means triangle FJG is congruent to triangle HJG. And luckily enough, you do not have to write this entire thing for your proof. Okay, you can just write S, S, S. Okay? And make sure you know what it means, because we're going to have more ways to prove that triangles are congruent, and not only just by SSS. So SSS stands for side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Okay? Example 2. Determine whether triangle PQR, so that's that upper left triangle there, is congruent to any other triangles. Okay, this is going to be a long one. So find the length of PQ. Well, we can count that. That's 1, 2, 3. QR, well, that's easy to count too. 1, 2, 3, 4, 5. Find the length of PR, so that's a diagonal. So we need to use the distance formula. Okay. So I need to label my points here. P is at -1, 2, 3, comma 1, 2, 3, 4, 5. And R is at 1, 2, 2, 2, 2. Okay. So I'm just going to do top minus bottom. So -3 minus 2 squared plus 5 minus 2 squared. Okay, and that'll give me -5 squared plus 3 squared, which is 25 plus 9, which is the square root of 34. I'm going to leave it like that. So that's PR. Okay, RS is 1, 2, 3. Okay. RT is 1, 2, 3, 4, 5. Okay, so far so good. Two of the sides are the same. Let's see if the third side is the same. ST. S is 5, comma 2. And T is 2, comma 1, 2, 3, -3. Okay, let's see if we get the same thing. So square root 5 minus 2 squared plus 2 minus -3 squared. So I'll get 3 squared and 5 squared again. So that'll be the square root of 34. Okay, so we know that PQR is, so triangle PQR is congruent to triangle SRT. So the reason why I paused there is because I needed to look at the corresponding points. So when we looked at PQ first, we looked at RS. PQ is the same side as SR. So I need to look at the corresponding points to name this correctly. Because PQ should be the same as SR. QR is supposed to be the same as RT, which it is. and PR should be the same as ST. Oh yeah, let's look at VW. Boy. Yeah, this is just straight up distance formula, distance formula, distance formula. So this is at -3, comma, -2, and this is at 0, comma, 1, 2, 3. 0, comma, -3. Top minus bottom again. -3 minus 0 squared plus 0 or -2 minus 3 squared. Let me write that a little bit more clear. -2 minus 3 squared. So I'll get -3 squared plus -5 squared. Did I do that right? VW. Oh, yeah. No. -2 minus 3 is -2 plus 3, which is +1 squared. So that'll give me the square root of 10. And we just need to stop right there. We don't need to find this or this because we know that this length here is different from all the other lengths. So triangle PQR is not congruent to, so you just put a slash through it. Triangle, whatever that is. VWR. Okay, example 3. Explain why the table with the diagonal legs is stable, but the table with vertical legs could collapse. So, in construction, we figured out that triangles are very stable. So, the triangle shape. Legs have fixed length form. Yeah, wait, let me pause this really quick. Alright, basically the triangles, since they're locked that way, they can't, like the angle, let me pause. Alright, so I'm just going to read it and then I'll explain. So, the triangle-shaped legs have fixed length and form congruent triangles, so it cannot change shape. So the angles are also fixed, which makes it stronger. So what it's trying to say is with the legs with vertical could collapse because you could tip the table basically so that the legs kind of lean that way. They change their angle and then they just fall over. Like you just push the table sideways and then the legs bend. Versus here we have these two the two bases there, and they form these triangles. These angles are kind of locked in place so that making the table more stable. But if that didn't make sense at all, but basically triangles are more stable than rectangles or boxes. So always, if you're building anything and you need to support it, use triangles. But basically, if you push this table, or the triangle table, if you push that table, it's not going to change shape. These triangles, they're kind of locked in place. You might be able to squish the table, but the table itself is being supported by the bottom. So if you push the vertical leg table just to the right, these legs could potentially bend and just the table can fall over. Versus if you push this table, it'll just slide. You would have to literally flip the table for this to fall. Alright, let's go move on from that. Checkpoint 1. Decide whether the congruent statement is true. Explain. So JKL is congruent to MKL. Okay? So JK should be congruent to MK, which is true, 8 and 8. And then JL should be congruent to ML, which it is, 9, 9. And then LK is congruent to LK. Yes. So 3 sides, SSS. Okay, let's look at RST and TVW. So RS, is that congruent to TV? So once again, these letters that I'm choosing the first 2 letters. Okay? And if those do not match, if those are not congruent, then the 2 triangles are not congruent. So RS, TV. Well, these are blank. Just so no. Unknown lengths. Okay. If these did check out, I would check RT, so first and third, and TW. So is RT congruent to TW? Yes. Yes, that's checked off. And then ST would be congruent to WV, but the first one did not work. So no, these triangles are not congruent, or at least we don't know for sure. All right, checkpoint 2. DFG has vertices. So DFG is -2, 4. Four, 4, 1, 2, 3, 4, and -2, -2. So there's that triangle. Okay, and then LMN has -3, -3. -3, +3. And -1, -3. Okay. And we want to know if those 2 triangles are congruent. So let's check. So 1, 2. So this is 2. And that side is 2 on the other triangle. And then the long sides, let's look at the long side. This is 6. And then 1, 2, 3, 4, 5, 6. So that's also 6. So we need to find out if that last side is congruent to the other last side. So I just need DF, this is G, or no, this is F, So this is 4, 4. That point there is G at negative 2, comma 2. Okay. So we have 4, 4 and negative 2, comma 2. And then sorry, lost my train of thought. Here we go. So that's 4, 4. So let's find, this is FG. So let's find the length of FG here. And that's equal to the square root of, I'm just going to do left minus right. So 4 minus minus 2 plus 4 minus 2. So this would be 6 squared plus 2 squared. So 36 plus 4 is the square root of 40. Okay, now let's look at the other one, which is, this is N, and then L, no, M, L, or NM, so M, N, and that's points negative 3, comma 3, and negative 1, comma negative 3. Just going to do left, right, minus right again. Negative 3 minus minus 1 squared plus 3 minus minus 3 squared. Negative 2 squared plus 3 minus minus 3 is 3 plus 3 squared. And we'll get 4 plus 36 again. So yes, by SSS S. Alright, so whether the figure is stable, explain your reasoning. Okay, this is stable because of congruent triangles. And then basically quadrilaterals. So I think this is like a trapezoid. Not stable. But basically the quadrilaterals can shift while the triangles cannot. So if you compare the left picture to the right picture, this is kind of locked in place, while this trapezoid here, you can push on one side and kind of move it. It's not really, you can change angles and then collapse the platform, or whatever the structure is. But basically, main thing you need to know, triangles, very stable. Four-sided stuff, not stable. And that is it for 4.3. Have a good day.